So far in the course, we have created a null and alternative hypothesis, then built a null distribution based on that. We built a distribution of expected sample statistics, assuming the null hypothesis is true. Then we've identified where our observed statistic falls on that null distribution, and then made a conclusion like the null hypothesis is plausible, or we have strong evidence in support of the alternative hypothesis. So far in the course, we've basically stuck with the idea that if a p-value is smaller than 0.05, then we say we have strong evidence in support of the alternative. If the p-value is bigger than 0.05, we've said the null is plausible. Why? Why have we picked a p-value of 0.05 as being this cutoff? Now, the reason I have done that this semester is because that is kind of the standard that is used in most statistics books. It's also the standard kind of used in many statistical studies out in the world. What I've been using is a significance level of 0.05. All right, here it is defined for us. Significance level. Significance level is a value used as a criterion for deciding how small a p-value needs to be to provide convincing evidence to reject a null hypothesis. So what really happens when a statistical study is done is one of the first things you do is you create a significance level. Oftentimes, especially in social science, they might pick a significance level of 0.05, which is what we've done. We're saying, if our p-value comes out less than 0.05, then we'll reject the null hypothesis and say that we have strong evidence in support of the alternative hypothesis. All right, so a significance level does have a symbol. We use the Greek symbol alpha for the significance level. The significance level does not have to be 0.05. It's kind of been the standard we've been using this semester in this course so far, but we could use a different significance level. The point of a significance level is this. If your p-value comes out larger than the significance level, then you don't have enough evidence to reject the null, and you conclude that the null is plausible. If our p-value is smaller than our significance level, we do have enough evidence to reject the null. A smaller significance level would mean that you need a smaller p-value to reject the null. A smaller significance level means you need a statistic further out in the tail for you to conclude that you have strong evidence in support of the alternative. So let's do one quick example of this. I'm going to do example 1. It reads as follows. We want to know if a new drug reduces the proportion of people who suffer from a certain side effect. The current drug that people use creates this side effect in 8% of users. So let me just pause there for a moment and make note. That's telling us our null hypothesis is that pi is equal to 0.08, meaning people who use this new drug are suffering the side effect at a rate of 8%, the same as before. The alternative hypothesis is that pi is less than 0.08, that on this new drug, they're suffering that side effect less than 8% of the time. We conduct a random sample of 240 users. So that's telling me N, the sample size, is 240. We find 5.2% of them suffer from the side effect. So that's saying in our sample statistic is 0.052. 5.2% of them suffer from the side effect. We're deciding to use a significance level of 0.01. So that's our new vocabulary word. Alpha is 0.01. The significance level is 0.01. That's telling us you have to have a p-value smaller than 0.01 to reject the null hypothesis. All right, the simulated distribution is shown below. So notice we put the value of the parameter from our null hypothesis here, 0.08. We have our sample size here, 240. We're going to do 1,000 simulations, so there's 1,000 dots shown here. We put our statistic p-hat here in the count area, and we use a less than because that's our alternative hypothesis symbol. Okay, it is centered, the null distribution is centered at pi equals 0.08, and it's counting samples that are like our p-hat of 0.052 and smaller. So it looks like if the null hypothesis is true, that pi is equal to 0.08, then the probability of getting a sample like ours or less is 0.045. 4.5% of the samples are like ours or less. Okay, so that's all kind of review there. So part A is asking, do we reject or do we fail to reject the null hypothesis? The answer to this is entirely based on the significance level. We're going to compare our p-value to the significance level. Our p-value is 0.045. The significance level is 0.01. Since our p-value is more than the significance level, we conclude that we fail to reject the null hypothesis.